Okay, this video accompanies section 1.6, which is the law of syllogism and the law of detachment. The first thing we're going to talk about is the law of detachment, and what that says is that if you have an if-then statement, like P, if P then Q, and let's say it's a true statement, and now if the hypothesis part is true, if we have a true statement and the hypothesis is true, then it follows that the conclusion must also be true. So that's the law of detachment. So given that a conditional and its hypothesis are true, if P then Q, true statement, how can you determine whether the conclusion is true? So if you have a statement that's true, then that means that if the hypothesis is true, the conclusion follows from it, so the conclusion is also true. So yes, we can. Let's look at example 2. We want to apply the law of detachment. So assume that each set of given information is true. So if two angles are congruent, then the measures of the two angles are equal. So angles congruent, measures are equal. So that's our hypothesis and conclusion. So P is going to be two angles are congruent. The conclusion is going to be the measures are equal. Measures are equal. And they tell us that this is a true statement. It says that each set is if true. So angle 1 is congruent to angle 2. So we've got this case where the two angles are congruent to each other, telling us that that's true from statement true, so it must be that the conclusion is true, and that tells us that the measures are equal. So to kind of recap, you have a true statement. So if this is a true statement, then if P is true, Q is going to be true. So in the second statement, they're telling us that P is true. Therefore, Q must be true. Okay, let's look at, let's go up and look at B. If you finish the race in under 30 minutes, then you win a prize. So for this one, I'm just going to use the notation. Let's do race in under 30 minutes. So you finish the race in under 30 minutes, and then that means you get a prize. So if R, then P. If you finish the race in under 30 minutes, that's the R part, then you get a prize. That's the P part. You finished the race in 26 minutes. So you got the R part there. Now they're telling us again, this is a true statement. So if R is true, P has to be true. So in the second statement, we've got R as being true. You finished in under 30 minutes. Therefore, P must be true, and you win a prize. Okay, to look at this habits of mind, if we go back to example 1, what would happen if angle 1 were not congruent to angle 2? So let's think about this. If two angles are congruent, then the measures are equal. So it kind of stands to reason that if two angles aren't congruent, the measures are not equal. So that would be sort of the if the measures are not equal, then the angles are not congruent. So that would be the contrapositive. And back in the last section, we saw that the contrapositive had to match the truth value of the original conditional statement. So if P then Q is true, then not Q, then not P also has to be true. And so that applies down to this habits of mind one here. So we would conjecture that, or we would be able to say that if the angles weren't congruent, or if angles weren't congruent, then their measures would not be equal. Okay. Now in this section we have the law of syllogism, and the law of syllogism is like the transitive property. So let's say we have x is equal to y, and y is also equal to w. So if x goes with y and y goes with w, we can make the link using the y, and that leaves us with x equal to w. And that's the transitive property, and that's the way that we use it in algebra. Another one might be if 7 is equal to x and x is equal to y, then we could say that 7 must be equal to y, and that uses the two x's as the link, or the transition, to transfer, and 7 gets transferred to y, and it kind of uses the x up as kind of like the hookup in the middle, just like this here. So that's the transitive property in algebra. The law of syllogism works the same way in logic and geometry. So if an integer is divisible by 6, then it's divisible by 2. So we get integer divisible by 6. So let's say D for divisible by 6, and that means it's divisible by 2. Now in the next, and they're telling us that this is a true statement. So divisible by 6, then divisible by 2. Now in the second statement, which is also a true statement, they're telling us that an integer is divisible by 2. And if it's divisible by 2, it must be an even number. So this kind of parallels this over here with the variables. The two t's serve as the link, and it leaves D connected to E. So we could say that an integer that's divisible by 6 is an even number. Okay, let's look at the next one. If it's a holiday, then you don't have to go to school. So let's see what we got out of that one. So if it's a holiday, then there's no school. Let's do NS for no school. So if holiday, then no school. Now the next one says it's Labor Day, and if it's Labor Day, it's a holiday. So let's see how we can connect these together. We can go, if it's Labor Day, then it's a holiday. If it's a holiday, then there's no school. The two H's in the middle link these together, and it leaves Labor Day means no school. So if Labor Day, then no school. Okay, let's look at number 4. Now this uses a combination of both. So if a statement is true, if a conditional statement is true, that means that if the hypothesis is true, the conclusion is true. That's the law of detachment. And then the law of syllogism says that if one thing gives you something else, then, and that something else gives you yet another thing, then the first thing is linked to the last thing using the law of syllogism, which is like the transitive property. So we're going to use that to try to figure out what's going on with this. So they're telling us that this is true. If a quadrilateral has 4 right angles, then it's a rectangle. So a 4-sided polygon with right angles is a rectangle. 4-sided polygon, same thing as quadrilateral. If a quadrilateral is a rectangle, then it has 2 sets of parallel sides. So let's do the variables that could go with this. So let's see. So four-sided quadrilateral, so 4Q gives us rectangle. The second one says if a quadrilateral is a rectangle, so if it's a rectangle, then it's got parallel sides. So if it's a four-sided quad, if it's a quadrilateral, which means it has four sides, that makes it a rectangle. And if it's a rectangle, it must have parallel sides. So let's see. So this polygon has four sides and four right angles. So the four sides makes it a quadrilateral, and it's got the four right angles. So the four went with the right angles, and the other went with the being a quadrilateral. So this polygon is the 4Q. It's got the four sides and the four right angles. It's a quad with four angles. Using the law of detachment and syllogism, what can we conclude? Well, that means it's a rectangle. But if it's a rectangle, it must have parallel sides. So this polygon must have parallel sides. Let's look at example 5. Suppose point D is in the interior of ABC, angle ABC. Use deductive reasoning to draw a conclusion about the measure of DBC. So let's sketch this so we have a reference. Let's draw angle ABC. And let's put point D in the interior of ABC. And then let's make it into angle ABD and angle DBC. And they're talking about the measure of DBC. So if this big angle ABC has an interior point D that makes two other angles, we can see that those two other angles have to be smaller than the original angle, because D being in the interior makes two angles that add up to the measure of ABC. So what can we conclude about this? The measure of angle DBC must be less than the measure of angle ABC. And that's it for this Student Companion 1-6.